be showing the Newman projection of propane. So first, we're going to start off with the eclipse form. And you can show it like this. As long as you show some kind of three-dimensionalness. And then you move 60 degrees and you get what is called a gouge form, which looks like this. So you see how it's moved a little bit. Whereas this next form, you move 60 degrees more, you're going to see the significant difference. And this is called staggered. And then you move another 60 degrees and you're at 180. So the transformation, you're going to be able to see that this one is going to be 180 degrees from this one, and this is called anti. Move another 60 degrees and you can see that we are trying to get back to the eclipse form once again. So we will then have stagger again. And then another 60 degrees will give us gouge. And then again, 60 degrees, we've done a full 360, and we are back at the eclipse. And now, we can move to problem 3.4, where it wants us to show the relationship between these two carbons in a gouge form and in an anti-form. So again, it will be like this. If you draw the circle, it helps a little bit. Make sure you put your hydrogens. And then a gouge is where it's just moved a little bit. And the anti-form of this
Alrighty, now we're going to make a change in pace. This is going to be problem 3.6, where it says the heats of combustions of ethyl cyclopropane and methyl cyclobutane have been measured as 3352 and 3384 kilojoules per mole, or 801.2 and 808.8 kilocalories per mole. And it tells us to assign the correct heats of combustions to each isomer. Now, the way I rearranged it is I have ethyl cyclopropane as this, hopefully this is the right structure, and I assigned it these numbers right here, and I assigned my methyl cyclobutane these values as well. Now the reason why I assigned these values is because even though ethyl cyclopropane is a fairly large carbon chain, going down, from here in this case, it's still a slightly smaller structure than methyl cyclobutane. Because as you can see, methyl cyclobutane has more carbons than ethyl cyclopropane. If we were to count in this case, 1, 2, 3, 4, 5, and you have 1, 2, 3, 4, 5. Oh, whoops. Well, it looks like they have the same carbons. Whoopsie doos. But anyways, as far as that's concerned, they're different in structure regardless. The fact that cyclobutane is more stabilized and like bulky overall makes sense how we have to assign 3384 kilojoules per mole and 808.8 kilocalories per mole, just because obviously a cyclobutane is bigger than a cyclopropane, regardless of what's attached to it and how many carbons it has. Same thing goes for ethyl cyclopropane. Even though, yes, it has the same number of carbon chains, well, it has the same number of carbons as methyl cyclobutane, it's still smaller in structure compared to methyl cyclobutane, which is why it has 3352 kilojoules per mole and 801.2 kilocalories per mole as its heats of combustions.